Hello, welcome to the live stream. It's me, Mecha Sparrow. Let's see. I'm gonna be doing some coding. Well, I'm gonna be starting some computer science stuff. Today it's mostly like programming related topics. So yeah. So I'm currently reading this book called. Here, let me check if I'm live, and then I will actually officially start. Okay, I'm live on YouTube, but let's see about also live on Twitch. So that's good. Okay, great. Okay, I'll close those out. I have the chat. Good. Let's see. Music. Okay, that should work out fine. Let's put this a little bit lower. Yeah, okay. Alright, so welcome to the live stream. I am Mecha Sparrow, and we will be getting started right now. So I'm currently studying this book called How to Design Programs. And it's by MIT, and this is the second edition, and right now I'm just going through the prologue where they're talking about just the basics of like a racket and stuff like that. And actually has some pretty decent ways of like programming and stuff. That's cool. Then they made an R function. So basically it's saying, hey, you can define variables, and you can define them. You should probably define them first before you define any functions. Anytime they use a semicolon, it's considered a comment. Then they have a couple ponderings. Drawing a UFO. How would you change the program so it depicts the landing green UFO? Well, this would create an image. So I could just probably put it here. Expected expression. Let's copy that image. doing there? That's stable. How would you change the program to create a 200 by 400 scene? Well, I would just change width and height. How would you change the program to so it depicts a landing of a green UFO? Considering that we're placing it on the scene, so we can define UFO as this stuff. Let's see if that works. Okay, so instead of using, is there any errors? No. So instead of using rocket, we'll just use UFO and see if that works. Perfect. But the UFO has a different height, probably about 10 radius, so 20 is the height. Image, well, I think we can just do image height. Let's take this, let's make a V6. And let's do errors. Perfect. Nice. Okay. Let's see. No. All right. How would you change program so the background is always blue? I would place a rectangle on top of the scene. How would you change the program so the rocket lands on a flat rock bed that is 10 pixels higher than the bottom of the scene? Don't forget to change scenery. Better than pottering is doing it. It's the only way to know. So don't let us stop you, just do it. Take another look at picture of rock V5 because we limited all repeat expressions. All but one number disappears from this function definition. In the world of programming, those numbers are called magic numbers and nobody likes them. Before you know it, you forget what role the number plays, what changes are legitimate. It's best to name such numbers. Here, we actually know what 50 is. 50 is our choice of excrement for the rocket. Even though 50 doesn't look like much of an expression, it really is a repeat expression. Thus, we have two reasons to eliminate 50, and we leave it to you to do so. 50, I would say, is the center. So we can just make it let's do UFO X chord. Let's make this the width divided by 2. Perfect. Let's run that. Okay, let's do that. Okay, great. So So testing. So let's make this a bit louder. That's better. All right. One more definition. Recall that anime actually applies its function to the number clock ticks that have passed since it was first called. That is, the argument of picture of rock isn't a height but time. Okay. Bracket 6. As you become a true blue, function definitions, constant definition, you also see that functions refer to each other all the time. What you really need to practice is organize them so that you can read them easily, even months after completion. After all, an older version of you or someone else will want to make changes to these programs. And if you cannot understand the programs for an transition, you will have a difficult time with the smallest steps. Otherwise, you mostly know what there is to know. No. I love the part where it's like it has that much space. Okay. When you look at programming bookshelves in a random bookstore, you will see a load turn you onto the programmer's spot, but that does not work. Great. So it doesn't actually have to use a bunch of math. Cool. Okay, let's get through. Let's have our initial goal of getting to. Let's just try covering three chapters today. That's our goal. Okay, I'll be right back. Gotta get something to. Okay, I have returned. Let's lower the volume of this a little bit. Yellow is not a good section to be in. Alright, there we go. Let's do that. Okay. So I'm kind of gonna probably change the music because it's making me feel a bit sleepy. Maybe this one. That's good. We'll use that one. Alright, so let's cover. I think I shall cover those 3 chapters to start. And then I'll cover. Or we'll see how long they go. Let's start with the first one. Okay, let's try it out. We'll see how it goes. That's better. Okay, so it just reduces down. That's fine. atomic data. Atomic data is number, strings, images, Boolean values. Can't get any simpler. Okay. Write down expression that computes the distance, and that is 8 point. Okay. Let's do, so define x3, define y4, define distance. Perfect. Okay. Now in our journal. Mm-hmm. Mm-hmm. Okay. Hello, welcome to the stream. Currently learning Racket, or a sub language of Racket, for just learning it. Create an expression that adds string primitives. I feel like I did it. Mm-hmm. Perfect. Oh, yeah, it works. No, my pencil. Okay. Mm-hmm. Mm-hmm. Because it's sunny. Any experience with Racket? Not really. I just know that you can create a bunch of domain-specific languages with it. I know that. And then also, like, this is what I'm using for the teach yourself. This is kind of like my reading list for the summer. Did it? Yeah. That's kind of my reading list. So I'm just like, well, it was on the list of stuff to read. So I was like, okay, I'll read this. And then besides Racket, I'm also teaching myself C. Well, it feels kind of academic though. But I can see a lot of applications for it. I feel like the most modern Lisp I've seen as of right now is like probably Clojure because it ties into JVM. So I've used Clojure a little bit, but the issue of Clojure is like because it runs on top of JVM, it's kind of has a slow startup speed, which kind of like is annoying for me, at least in my opinion. Let's see. Okay. One important use of Boolean values. Mixing it up. Inverse, cool. Works fine as long as we don't have it be 0, which is okay. We can say, well, we can use the if expression. Okay, cool. If blah, return 0, else do the computation. Okay. So this is if else. That makes sense. Given the definition of X, you can experiment with expressions in interactions area. What section am I at? Oh, I'm still on chapter 1. Okay. Given the definition of X above, you can experiment with if expressions in the interactions area. If blah blah blah. 0, 1 over X, and then I guess X is 2 in this case. Yeah. JVM is like NES development at this point. Yeah, I have one of my best friends. I need to get him to learn Racket actually, because this is pretty fun. He's like his main language is Java, which is like that's the reason why is because a lot of the high schools, at least in my area, they teach so any AP computer science class, at least in I guess the United States, they test the thing in they proctor the exam in Java. So it's like they teach you introduction to computer science with Java, which in my opinion I think they should I would prefer them to do AP computer science with C, because C is actually would probably be a lot better in the long run for them to know that, because like C does not give you any helping. I mean, it gives you some helping hands, but it's a lot less forgiving than say Java. Java is like probably kind of bloated, to be honest. Dr. Racket knows because X stands for 2. Because 2 is not equal to 0. Same result. Oh, it's because it's reduction. If you edit to 0, what will the result be? That will result in 0. Yeah, it's okay. I mean, what I mean is like it's okay as in like there's some parts where I'm like, okay, that's better than nothing. If it's better than nothing to start with. But I mean, you can say that with almost anything though. You can say, well, that's better than nothing. Strings aren't compared. Okay. So you have to use, okay, you have to do string and then the comparison question mark. Is this string? Does it compare to the other thing? Okay, yeah, I can do that. Other one, oof. I guess comparisons like, I don't know why. Let's see what this is. You may wonder why is it necessary to compare strings with each other. So imagine a program that deals with colors. The next color, if it is equal to green, switch to yellow. If not, switch to red. Okay. It should be easy to imagine that this fragment deals with computation that determines which light bulb is turned on next and which one should be turned off. Yeah, that would be, that's something. One of the colleges I was looking at, when I was looking at colleges, I had two, I was like looking at two, and one was like, yeah, so we teach our introductory class in Java, and the other one's like, yeah, we teach our introductory class in C, and I'm like, well, I think C is gonna be better for me, so I'll just stick with that. Ooh, cat again. Create conditional expression that computes whether the image is tall or wide. An image should be labeled tall if its height is larger than or equal to its width. Otherwise, why are you learning a Lisp? As I said, I don't know if I linked it. I don't know if it showed up in the chat, but basically there's this curriculum I'm looking at, which is called Teach Yourself CS, right? Because I want to just do a bunch of computer science stuff before I go to college, for kicks and giggles. And there's a couple subsections, and in the programming subsection, they're like, for just general, like how to structure programs, how to design programs, or like either use SICP, which is scheme, right? Or if that one's too complicated, which I feel like it is, because it's really math heavy, and I mean, I love math, but I feel like there's too much math in it. There's another one, where it's how to design programs, which is a much more simpler version of SICP. There's some overlap, which is good. Basically, and those are both like Lisp stuff. Like it just happens to be Lisp. But honestly, like the concepts they're teaching here, it could not necessarily be a Lisp, but they chose to use a Lisp, and I'm like, okay, why not? Am I gonna realistically use Racket in a different context? I don't know. But yeah, that's why I'm doing HTTP instead, because seems a little bit more kinder, a little bit. It's the guy's like, yeah, we're not using any like crazy math. Okay, so we can say define cat. Okay, labeled tall. Let's do define get orientation. Let's do that. So we can say that will be equal to if let's do define cat width to be image width of cat, define cat height to be image height of cat. If the height is larger than, so if the cat height is larger than or equal to its cat width, then we can say it's tall or it's wide. Okay, get tall, and then that makes sense. Yeah. Okay. And if it is not, we can say, okay, if it's greater than cat height, then it's tall. Then we can say, we can nest another one. If it's yeah, I mean, it's that works, I guess. Let's see. Know thy data. Predicates. Reduction. It's quite often you deal with variables that may stand for either a number or a string. You can always check if it is one of the things by using those comparisons. That's good. For different, use a predicate. Determines whether or not it belongs. Okay. Okay. All right. As you see, predicates produce Boolean values. Hence, when they're combined with conditionals, programs can be protect. Okay. I have a feeling that for this, I think I can just do conditional. Can I do that? Okay. That's definitely way better. Okay. Nice. You even have complex numbers in this. So I guess it would be good for, like, I guess I could do fractals in here. Fractals would be nice. Put square root -1. So what you see is a so-called complex number. It's a rational. Is it complex? Oh, it is complex. That's great, computer. Then you can also say, is pi a exact number or a not exact number? And pi is not exact. Create a expression that converts a value of the input into a positive number. For a string, determine how long the string is. For an image, you uses the area. For a number, decrements the number by 1. That's too much. I understand. I know how to do it in theory, so that's good enough. Now relax, eat, sleep, and okay, I don't feel like sleeping. It's not time to sleep. Okay. Functions and programs as far. Oh, was that chapter? Okay, that was chapter 1. All right, let's put that on the. This is web whiteboard. Let's keep track because I don't know why not. 1. Okay. Functions and programs. As far as programming is concerned, arithmetic is half the game. Other half is algebra. Oh boy. Okay. Notations in the fun and accessible. Okay, let's do it. Constant definitions is when you define variable expression. Okay, got it. Function definitions is very similar, but they come in multiple flavors. You can list as many variables as you want. Okay. Function name, variable. name followed by several. That's all there is to it. So I can have as many variables as I want. The first one is actual name of the function. Okay. Then the expression afterwards comes afterwards. Before we explain why these examples are silly, we explain what the function... Oh, because you're not using any of the arguments. Okay, examples are silly. Since variables are about inputs, not mentioning them in the expressions means that the function's output is independent of input, therefore always the same, which means that why in the world would you actually add inputs? Or just have it be a variable. Variables aren't data, they represent data. Constant definition, such as define x3, x stands for 3. The variables in the function header are placeholders. Okay. Consider the following fragment of definition. So FF, meaning FF consumes one piece of input. Whole point is defining a function that we can use multiple times on different inputs. Useful function bodies refer to functional parameters. Reference to a function parameter is really a reference to a piece of data that, okay. We are saying that the output of the function is 10 times its input. Presumably this function is going to be supplied, okay. For now, the only real remaining question is how a function obtains its inputs, and that's up to us. Function application puts defined functions to work, and it looks like applications of predefined operations. So functions basically specialized operation. Okay, got it. What does f circle 3 solid red yield? What is our f function? Well, if everything returns 1, where's f? Okay, it's gonna return 1. That was a trick question. Can't give it because it needs 1. If you give it too many, it's gonna be like same for all the other operations. They're nestable, that's cool. Define a function that consumes 2 numbers, x and y, then computes the distance from... I already did that, but fine, why not? So let's compute a function. Define distance x, y. Let's say that is the addition, that is the square root of x squared and the sum of x squared plus y squared. And let's do 4, 5, or no, 3, 4. Distance 3, 4. Perfect. Define the function cvolume, which accepts the length of a side of an equilateral cube and computes its volume. If you have time, consider C surface 2. Equilateral cube. Cube is also equilateral cube. That's not that. It's just L cubed. Okay, that's fine. Develop. Add a header. If you have time, consider defining C surface. An equilateral cube is a 3-dimensional. Oh, I should have seen that. Container bounded by 6 squares. You can determine the surface of the cube if you know the square's area is the length multiplied by self. Its volume is the length multiplied by the area of one of its cubes, which is just cubic. Y. Counter. Oh, it's just okay. Fine. Define the function string first, which extracts the first one string from a non-empty string. That's fine. Function string last, same thing. This is basically saying it answers true if sunny is false, or Friday is true. So it's saying that if it's not sunny, that implies that it's true. Okay, this is like some specialized logical operation. Define image area, I already did this. Define function image classify, I already did this. This is all just functions. Okay. Nice. That's actually really cool. Oh, it creates just does that. Oh, it could use a like a loop maybe. So this would evaluate to, first it goes not x. So that'll be false. Or false.
Hola familia, it's Daddy Yankee, the Big Boss. Keep dancing and listening to Lura in the new YouTube Music app.
What do you expect as the value of this program? It's going to get a substring from 0 to I. It's going to insert s, and it's going to insert a underscore at I. So it's 0, 0, 1, 2, 3, 4, 5, 5. I'd say it goes hello underscore with the W, and after the W it puts an underscore. That's so bad. The owner. At a price of $5 per ticket, 120 people attend a performance. For each 10-cent change in ticket price, the average attendance changes by 15 people. That is, if it's this and it reduces, if the price goes down, average attendance increases to 135. Okay, explain the minus sign before you proceed. So initially you get 120. Minus sign represents the amount of people that don't come as a function of change in price. It's just multiple pieces. You do it one step at a time. You combine it together. Profit will be a combination. Constants, we already talked about constants. Almost pi. Empty scene. Most of our sample definitions employ literal constants on the right hand side, but the arbitrary expressions, okay. For every, oh, good one, okay. For every constant mentioned in problem statement, introduce one constant definition. Define constants. No, I'm not doing that. You are ready. Gets all its inputs at once, computes its result. Interactive consumes many inputs, computes, produces, compute, okay. Interactive, event-driven. These functions are called event handlers. When we launch an interactive program, the main function informs the operating system of its description. As soon as input events happen, the operating system calls the matching event handler. Okay. Book. Focuses. You'll get to know those. We create such file-based batch programs with the batch.io library, which gives us read file, write file. These functions write strings to files and read strings from them. So stout is a special symbol token that we can just use if we want to bypass writing it to actual file. Okay. By analogy, read file accepts stn in lieu of a file name. Okay, let's try that. So we're gonna get let's do define, say hello. Let's do language record. Let's add a teach pack. Let's do batch.io. Okay. Then we can do read file. Standard input. Can I just do this? EOF, nice, okay. Hello, friend. Then we can say, what is your It's weird how it does it, but it's fine. that works. Cool. Then that's similar thing here. String input, blah blah blah. String number. Where's this number? Write file out. Where's the to out thing? This long list of steps might look overwhelming. It doesn't even include string append part. Stop. Explain. String append. That. Just puts it on a new line, I think. Taking care. World programs. Now try the following Big Bang expression. Big Bang, 2 draw, 100, 2 draw number square. Take the number, 100, takes, this is our initial state. We call the function. And it's like, okay, we're gonna draw this, but we never change the state. Okay. More interesting Big Bang. Big Bang, 100, 2 draw. Untick, subtract 1 from the state. Stop 1, 0. Okay. Let's try that. Let's try that. Define circ number to circ I think I'm missing something. Solid. Okay, let's do. There we go. And then we can just use this. So it's subtracting 1, so it's going to give us a shrinking circle. Wow, okay. That's cool. So on key returns the state, a new state. Count to 10. S is the state, KE is the key. S. So it's assuming it's like a state machine then, I guess. And that's why. On tick, on key, on mouse, to draw, stop one. Big Bang is basically us creating a universe. On key, on tick, on tick, on tick, on keypad, on release, on mouse, on to draw, stop one, check with, record, close, on stop, display mode, stage. Okay, that's quite a bit. Talk, key, tick, talk. Talk is tick tock. On tick is so what will happen on. That makes sense, okay. Mm-hmm. If the key is A, mm-hmm. 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 Main actually starts the program. How many chapters? No, I got to chapter 3, so that's good. Okay, now we're gonna do some C programming. Let's do. Okay, I will return. Okay, so now we're gonna do some C programming for an hour. And then we'll see how that goes. Okay. And like, I mean, relatively, okay, there we go. Relatively speaking, I know most of these concepts, but it's gonna like hit me like a brick wall once it's like, hey, by the way, we're doing blah blah blah. So I'm just better. It's probably better just to like refresh before I get into the deep waters, I suppose. And then hopefully I'll do some game development after this, which will actually be quite relaxing. So that's the if else whatever. I know what that is. Switch statement. Switch statement. You have a expression, so some value, whether it's a string, a number, and then you test for each case. So if it matches a number of constant integer values. So I guess you can't do like a string because the string is like a char array. So it's but you can. There's probably other ways to do it properly, but that's fine. It's fine, I think. And okay. We wrote a program to count the occurrences of each digit white space and all other characters using a sequence of if. Here's the same program with switch statements. Okay. So they're using chars because, you know, makes sense. Because a char can be converted to an ASCII integer. N digit. Okay, makes sense. That looks better. Break statement causes immediate exit from the switch, but two cases serve just as labels. After the code for one case is done, execution falls through to the next one unless you take explicit action to escape. Break and return the most common ways to leave a switch. Break statement can also be used to force immediate exit from a while, for, and do loop, as will be discussed later in this chapter. Following through cases is a mixed blessing. On the positive side, it allows several cases to be attached to a single action, as with the digits in the example, but it also implies that normally each case must end with a break to prevent falling through to the next. Falling through from one case to another is not robust, being prone to disintegration when the program is modified with, okay. Put a break after the last case. Even default. Even though it's logically unnecessary, someday another case gets added, then this will save you. Okay. Write a function. Escape test converts characters like new line tab into visible sequences like /n and /t as it copies the string t to s. Write a function escape st that converts characters like. Okay. Sounds fine. Don't save. Quit. Or unnamed prototype does not allowed when bodies. I forgot how to do arrays in C. Okay, so we can say we don't need this. Let's do int I equals 0, I, then we'd say s of I not equal /0, I plus plus, print f. Print f constant char, but is of type int. Okay, let's do C. Does that work? Note. Oh, it's a note. Perfect. So then we can say, well, CompSci. We can say, well, we can say default is this. Let's say we have case like /n, then ti equals I'll get back to this one. Okay. Infinitely abusable. Mm-hmm. I think that's enough for today.